It's a summer afternoon in the Persian desert, roughly 2,400 years ago, and the air is somewhere north of 45 degrees Celsius. There's no electricity anywhere on the planet yet, obviously, and there won't be for another 2,000 years, and someone hands you a piece of actual ice, solid, cold enough to hurt your hand a little, something you could drop straight into your drink, not something hauled down from a mountain that morning, something made from scratch right here in a landscape where the ground itself is basically an oven. So how exactly do you manufacture ice in a desert with nothing but mud, water, and physics? The building where this happened has a name that still means something in Iran today. Yakhchal, literally ice pit, and in modern Persian, it's simply the word for refrigerator. From the outside, a yakhchal looks less like a piece of engineering and more like a giant beehive made of mud. Some tower 20 meters tall, roughly the height of a 6-story building, with walls up to 2 meters thick at the base. And those walls weren't just packed earth. Persian builders mixed a specific mortar called sarouj, combining sand, clay, lime, ash, goat hair, and egg whites into a material that was both waterproof and an excellent insulator. It sounds more like a recipe than a construction material, but it worked. The finished structure could keep its underground chamber cold for remarkably long periods, even while the climate outside was doing its best to cook everything in it. But storing ice through the summer is only half the story, because first, somehow, they had to make it in the desert. Here's the trick, and it genuinely sounds like it shouldn't work. Next to many yakhchals, engineers built shallow, stone-lined pools, deliberately positioned with tall shading walls on one side and completely open to the sky on the other. At night, workers flooded these pools with a thin layer of water, supplied through underground channels called qanats. These aqueducts could carry water for miles, often from distant sources, while keeping much of it protected beneath the ground. And on the right kind of clear, cold desert night, that shallow layer of water could freeze. But here's where it gets strange. The surrounding air wasn't necessarily doing all the work. The water itself could lose heat by radiating energy upward into the open night sky. On a clear, dry night, that sky acts like an enormous heat sink. The water sends heat upward and keeps losing it. The pond wasn't simply losing a fight with cold air, it was losing a fight with the universe itself, and the surrounding air barely got a vote. Every night this worked, the ice had to be collected quickly. As dawn approached, workers could break the newly formed ice into pieces before the rising sun began warming everything again. Then the ice was moved into the yakhchal's underground pit, where it could be packed and insulated for storage. And that's where the second half of the engineering began. Once the ice was safely inside, keeping it frozen through the brutal desert summer took its own kind of engineering. Many yakhchals worked alongside wind-catching structures called bad gears. These were towers with openings built high above the ground, designed to catch moving air and help circulate it through the structures below. As warmer air rose and escaped, cooler air could be drawn through lower spaces. In some systems, underground channels and shaded passages helped keep that incoming air cooler before it reached the storage area. No motor, no electric fan, no electricity, just architecture, airflow, insulation, and physics. The thick walls of the yakhchal slowed heat from entering. The underground chamber took advantage of the naturally cooler temperature below the surface, and the airflow helped prevent hot, stagnant air from simply collecting inside. Together, those simple ideas could preserve ice long after the nights cold enough to produce it were gone, which meant something remarkable. You could walk through a Persian city during the heat of summer with the sun beating down, the streets baking, and somewhere beneath one of these enormous mud structures, there could still be ice that had survived for months, without a refrigerator, without electricity. And this wasn't necessarily something that existed only for a handful of kings. Yakhchals became an important part of life in cities such as Yazd, Kerman, and Isfahan. Some were large communal structures. Others served smaller groups or private properties. The ice stored inside could be used to chill drinks like sharbat and to prepare frozen foods and desserts associated with Persian cuisine. One of the most famous is faluda, thin noodles served in an icy mixture, traditionally flavored with ingredients such as rose water. Versions of it are still eaten in Iran today. Think about that for a second. Thousands of years before anyone could plug a refrigerator into a wall, people living in an extremely hot and dry landscape had developed an entire system for producing ice when conditions allowed, storing it underground, and keeping it available long after the cold season had disappeared. And the most remarkable part might be how familiar some of this engineering looks today. Modern architects interested in passive cooling have gone back to ideas similar to traditional Persian wind catchers. Instead of forcing air through a building with electricity-hungry machines, the building itself can be designed to work with natural airflow. And researchers studying radiant sky cooling are exploring the same basic phenomenon that helped those shallow pools lose heat beneath a clear desert sky. Surfaces radiate heat upward. The sky provides somewhere for that energy to go, and under the right conditions, useful cooling can happen without a conventional refrigeration system doing all the work. 2,400 years later, we're still exploring ways to exploit the same basic physics, which makes the Yakhchal feel strangely modern. Not because the Persians somehow understood thermodynamics the way an engineer does today. They didn't need to. They observed what happened. They learned which materials worked. They learned what the desert did after sunset. They learned how air moved through a building. And generation after generation, they turned those observations into architecture. So picture that piece of ice again. It's sitting in your hand under the punishing Persian sun, slowly beginning to melt. Nobody mined it from a glacier that morning. Nobody shipped it in from somewhere cooler. No compressor is humming somewhere behind a wall. That ice had been made right there in the desert, then protected for months beneath the ground, using mud, water, air, and a night sky that had been there the entire time. The water lost its heat to the open sky. The Yakhchal kept the desert from taking it back, and somehow, thousands of years before electricity, some very clever people figured out exactly how to arrange both.